questions there.
7 and 8.
7 and 8. Number 7. Write two monomials with a product of negative 84a6 b10. So first of all, give me two numbers that multiply to negative 84. There's not just a right answer for this. You could have multiple things. Then I need two a's that whenever I add their exponents, they're going to give me 6. 2 and 3 works. 1 and 5 works. It doesn't matter. That's the point here, is it doesn't matter. Oh my gosh. Now two things that add to 10. There's an example. Yours might look a little different because you could have chosen different numbers, and that is okay. Yes. Number 6. Number 6 is a division one, so I have 15x squared y times negative 6x7y over 3xy to the second. So I'm going to clean up top first. Let's see. 15 times negative 6. Nobody's got any exponents, so I'll just multiply them like normal. 30, 60, 90, negative 90. And then I got x2, x7, so x9. And I have y1, y1, so y2. On the bottom, I'll go ahead and take this to everybody. 3 squared x squared y squared. This is really negative 90 divided by what? 9. What's negative 90 divided by 9? Negative 10. That's exactly right. Yeah. 9 minus 2 is 2 minus 2 is 0, and that cancels. Yes. Number 3. Negative 4a cubed b squared squared times 3a squared b. I'm going to distribute the squared first through there. Now, here's where things get a little bit tricky, because what happens when you square a negative number? It becomes positive. So really, this is like 4 squared a6b4 times 3a squared b. And again, the only reason the negative is dropping off is because I'm raising it to the second power, and a negative times a negative is a positive. So this would be 16. I've got A6 and A2, which would give me A8. I've got B4 and B1, which would give me B5, and I've still got that 3 there. And so I'll just multiply those together. What is that? 48? 48. Which other one did y'all say? 4. Number 4. Oh. Tell me when you got it. And move out of everybody's way. You can't just sit there. Okay. Number 4, 5c negative 7d2 times negative c d second to the 4th. This is going to be another one of those scenarios, because I'm raising it to the 4th power. The negative is going to kind of go away, because a negative times a negative times a negative times a negative is a positive. It's a good lesson to learn, because we'll talk about this a little more today, but if you raise it to an even power, it's always positive. If you raise it to an odd power, it keeps the same sign. So I'll get 5c negative 7d2 times c4d8, and now I can put together what goes together. 4. No, it doesn't matter. This would be c negative 3d10, and of course I can't keep a negative in there, so I'm going to move it down to the bottom, and I'll have 5d10 over c. What else? 8. Yeah. Yeah.
Just to make sure I got this right. If we ever have an exponent on a number, we just always do that exponent and then we, right?
Unless you're multiplying through and there's another base. There's another. Add the exponents, right? And then, yes. You could, or you could leave it like that. Man, if there's, especially if there's nothing else to work with it to simplify. Just leave it. I think so, in my opinion. The what? I'm not sure what you mean. Like distribute, you only distribute when you're adding or subtracting inside the parentheses, never when you're multiplying. Number 8 asks us about a cube, and it says that the side length of a cube can be represented by the expression 2x to the 5th. The side, if we double the side length, so if we double this, we'd be timesing by 2, right? So the new side length would be 4x to the 5th. So if we double the side length, write an expression to represent the new volume. Well, tell me how you find the volume of a cube. Y'all can do this. How do you find, okay, a cube is made up of what on all sides? Squares. Squares are special. No. Squares are special because every side length is the same, right? So all of these are the same no matter where I go. They all have the same length. So if I want to find volume, volume is always length times width times height. You always take the area and multiply by the height to get volume. Y'all don't remember that from geometry? No. Okay. Since it's a cube, I know. You didn't have to say it. Since it's a cube, I'm just gonna, they're all gonna be the same, right? So I'll do 4x to the 5th times 4x to the 5th times 4x to the 5th. Length times width times height.
Only thing I remember from that class is cubes because we did it for like 3D. Actually, it wasn't true. It was two false statements. I was awful. Because no, I didn't find on the test. I only 100 in class. It's just the two false statements. Like
okay. Negative 1/2 k cubed plus 3/4 k to the 5th. What's it say? Write in standard form. Is it in standard form? No. What does it need to be in standard form? Flopped around. That's the biggest exponent down to the smallest. That's all you had to do for that. You didn't have to do anything else. It just said write in standard form. It is a quintic binomial. Sorry. Quintic binomial. What's the leading coefficient? What's the degree?
5.
What's the constant? 0. Because it's not there.
Word.
All right, what else? 14. So I have 2a squared b minus 5b cubed plus 4a to the 4th b squared minus 7b cubed plus 8a 4b2 minus 7a 2b. Great, googly moogly. Okay.
This isn't hard. It's just It's just adding.
All right, tell me what we're doing. Tell me what to do.
You're just adding.
You're just adding. I'm going to go ahead and change all the signs here. Oh, shoot.
Double negative. I had everything else. What number are we on?
Possibility.
We do have. Wait, why did you make that?
All right.
Why did you make all that positive and negative?
Because it was subtraction.
So subtraction changed everything.
Yeah.
Man, bro, I don't.
Here's how I go about these that look kind of funky, right? I'll start with the first one, and I'll say, do I have anything else that's a squared b? A squared, oh, here's one, a squared b. So I've got 2a squared b plus 7a squared b, which gives me what? 9a squared b. I'm done with those two. I mark them out. This is just how I go about it to keep it straight in my head. Now I'll go to the next one. I've got a b cubed. Do I have any other b cubes? Yes. The answer to that is yes. Say yes, because yes. What is negative 5b cubed plus negative 7b cubed? Negative 12b cubed. And I'm done with that one. A to the fourth b squared. So I've got 4 and negative 8, which gives me, close, negative 4a to the fourth b squared. Yes. It was a subtraction, so I did a same change everything. You don't have to. If you don't, just be very careful and be able to go, okay, what is 2a squared b minus negative 7a squared b?
Oh, so we don't.
You don't have to change everything now.
Okay, sorry.
Yeah. If you still got the answer right without changing it, that's perfectly fine. Yeah. What else? Which one? 19. 19 is a nice little division problem. So since I'm dividing by a binomial, nope. What am I dividing by? Look at number 19, a monomial. That's exactly right. I'm dividing by a monomial. There's just one term. I can split this into 3 different fractions, okay? So I'm going to make it negative 42x10y5 over 6xy plus 12x8y cubed over 6x squared y minus 6x squared y over 6x squared y. And now I can evaluate each one independently. When there's no plus or minuses in the bottom, only in the top, you can break it up. I can simplify 42 and 6 to what? Negative 7. 10 minus 2. 5 minus 1. 12 divided by 6. 8 minus 2. 3 minus 1. Uh-oh. I see 0 and I see 1. Which one is it? 1. Why is it 1? Anything divided by itself is, of course, 1. No, it's 1. What else? Yes. Remember, you never want to multiply more than 2 at a time. So what I'll do is I'll take 2 and then I'll multiply by the third. Since the last 2 are a little more complicated, I think I'll multiply those 2 first and then I'll take it. Now, if you did the first 2 first, that's fine. And then take it to the third. It really doesn't matter. All right. 40x minus 10x squared plus 8 minus 2x. And I'm just going to clean that up just a bit. Negative 10x squared plus 38x plus 8. I just put it in standard form, combine my like terms there. Oh, yeah. And I still have this negative 3x that sits out there. Y'all all okay? Now I'll multiply the negative 3x through. 30x to the what? Third minus, no, yeah, x squared minus 44x.
Hey, so I did 3x.
That's fine. You should be in the habit, get in the habit of doing that. It's not wrong if you don't. I wouldn't mark it wrong just yet, unless the directions said make sure your answer's in standard. Classify that polynomial, by the way, while we're here. Cubic trinomial. That's fine. You should still have the same answer at the end. Yeah. 20. Same thing with 20. I'm going to split this fraction up since I'm adding up top, but in the bottom, I just have the one monomial. And so I have 16a4 over 12a cubed minus 40a squared over 12a cubed plus 24a over 12a cubed. I don't know why. If we don't have another test, it will. So. All right, 16 over 12. What's that simplify to? What? 4/3. And then 4 minus 3 is 1. Charlie. $100 points. But I'm going to let the combined of them replace your quiz grades since it's only 100 points. You see what I'm saying? Instead of taking your test grade and letting that, I'll combine it with the quiz. I'm just combining. Everyone did the project. 40 over 12. What's it reduced to? Guys. 10 over 3. Thank you. And then look, if I've got 2 A's up top and 3 A's in the bottom, how many does that leave where? 1 on the bottom. You don't have to. Because there was more in the bottom than the top. So if you subtracted them, it would actually be, I'd actually have 10 over 3, a to the negative 1, and I'd need to move it down. 24 and 12. 2 over 1, and then 2 A's in the bottom.
Hooray!
What do you mean? Anything else? I think we've done almost all of them. No. All right.
I just want to see if you noticed. Oh, Miss McGee, you're such an helper. Notice. That would have been great if you would have been writing and talking to us. That would have almost happened.
Karen starts our graphical analysis that will stay with you through calculus from here out.
I will be with you next year, maybe. Because my guidance counselor, she was like, well, the field you want to study, you probably need to take problem sets. And my mom's like, well, whichever one's easier.
What do you want to do?
I want to be a doctor.
Then you definitely need
No,
the calculus route.
I'm not being a doctor for real. I want to be like, what I need is what
If
my
you're going into any type of like STEM field, you need
sportsman, do I need pre-cal?
pre-cal, definitely.
Well, I don't want to be a senior in here with a bunch of like 11th graders.
Why will you be are you a junior this year?
Yeah.
Are you?
Yeah.
You won't be the only one though. I had a few juniors in there this year.
Sophomore with us.
Oh, see, shut up.
No, but I'm talking about like my senior year. If I'm taking pre-cal, I'll be like, no.
Why you won't take it your senior year? You'll take it next year.
So I should change it. But I'm gonna be an academic weapon next year.
If you do that through Central, it is hard.
Oh, but alright.
It's hard. It's a lot harder than here.
Where's problem stats like easy though?
Huh?
Problem stats easy.
I just say that because I've got a couple of honors kids that did that. They failed out or did terrible on it, and it tanked their GPA.
So pre-cal, then problem stats.
Yes. That's if you insist on taking pre-cal, that's the order you should do.
Because like,
I like calculus myself.
well, I don't know about all that.
As math goes on, algebra 2 is hard. Pre-cal's kind of tough. Calculus to me is the easiest. If you've already made it through pre-cal, you might as well do calculus because it's yes. Probably the foundation makes it easier too.
Well, I might need to change
The
that.
calculus concepts are not hard. It's the algebra that you use to get to the calculus concepts that make it hard.
Are you the only pre-cal teacher?
Honors. Yes.
Don't worry, I'm a pass now just so I can stay in honors so I can see you again next year.
And we may
Oh, I have to process.
Yep.
Just to let you know.
Describe the end behavior.
As X approaches negative
As
infinity.
x approaches infinity, so that means I'm looking at what? The positive side, the right side, right? Because as x goes to this is x and this is y. So as x approaches positive infinity, what does the graph do?
X goes to
It goes up, it goes to positive infinity, right? How about the other side? What does the end behavior look like? As x goes to negative infinity. Okay, so we've done this where we looked at a graph and we analyzed it for the end behavior. But what if I just gave you an equation and not a graph? I might be in a little bit of a more difficult situation, right? So I'm going to give you, this is a very, very important chart. Put it somewhere where you can reference it in your notes. You'll keep looking at it until you can remember. So as it turns out, I could classify polynomials by their leading coefficient and their degree, and it would tell me what the end behavior is going to look like. So I'm going to set 4 squares here. And I'm going to classify LC would be the what? What's that mean? Leading coefficient or degree. So I'm going to say leading coefficient here positive and positive, and then in the last 2 squares I'll say leading coefficient negative and negative. And then for my degree, I'm going to base that on if I am even or odd. So I'll say even, odd, even, odd. Every single polynomial in the whole wide world that is positive leading coefficient and even degree has the same end behavior. No matter what happens in the middle, how many humps it has, how many times it goes up, down, left, whatever, the ends look exactly the same. Every positive odd, every negative even, and so forth. So we can use this chart to tell what the end behavior is going to look like. So I'm just going to fill it in for you. You could actually derive this yourself, and we'll talk a little bit more about that whenever we have a little bit more time. But if you could think of an example of a polynomial with a positive leading coefficient and an even degree, say like a quadratic that goes up, it could help you come up with this end behavior. So in this square, as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x still approaches infinity. So if I start out with a positive number and an even degree, then both ends of my graph are going up. No matter what's happening in the middle, they're both going up. Have we done the chart like this? Okay. If I'm still an even degree, so I'm thinking a degree of 2, 4, 6, 8, and so on, but my leading coefficient is negative. So think about like a parabola that's going down. Both ends are still going the same way. It's just that now they're both going down. All right, let's look at positive and odd here. So leading coefficient being positive and degree being odd, think about something like a line. The ends are going to go in opposite directions. As x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity. And again, I know that I'm going through this kind of quick. Normally I would have you derive and come up with, but just so that you have enough information. Yeah, I know. I know you're excited. Glad I could help with that excitement. Tell me this. Let me give you an equation. Keep this. This is not part of the chart. This is just an example. Let's say I gave you this polynomial. What is the end behavior of that polynomial written over on the side in purple? See the negative 3x to the fifth? Hello, you need me? Charlie? No, it's okay. Go ahead.
As x approaches
Tell me which quad, which one you're in. All right, so we're looking at which one it goes in. It's this bottom right? Because the leading coefficient is negative and the degree is odd. So all I would do is I would take this and copy it for the end behavior for this one. So the end behavior of this would be as x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches infinity. Yes, no, maybe so?
How do you know that Jennifer?
Huh? Oh, she got a sheet. They didn't say your name. They must have missed you.
Why are y'all leaving?
Why are you nosy? Now they're calling.
Here, let me answer.
Does that make sense? Do you see how we're just referencing the square that it goes in and just copying the information that's there?
Oh, wait. Oh, I got it.
Right? It's pretty easy. All right. I